All right, this is the Math 3 notes for Unit 2 for graphing systems of inequalities. And so this is going to be very similar to what we were doing with graphing. We're going to use some of the same shapes that we've worked with before, but we're going to add a couple things in here. Instead of graphing equations, we're going to graph things with greater than or less than or greater than or equal. And so we're going to introduce a couple things. First of all, sometimes, like in step 1 here, sometimes we'll be dashing the line if the values are not equal, if you just have a less than or a greater than sign. Other times we'll use a solid line if we have that equal sign along with the less than or the equal. So we'll be asking the question, should it be dashed or not? The second thing is the shading. If sometimes we shade above the graph, sometimes we shade below, and you can refer again to your notes in this part that I'm circling. If it's less than or equal, you're going to shade below the graph. If it's greater than or equal, you'll shade above the graph. So with that said, let's take a look at the first example. It says to graph the system of inequalities of the graph provided. If the solution exists, then name 2 points on the solution set, and we'll see the answers may vary. So we have 2 equations, and I'm going to try to color coordinate here for you. The first equation that we're going to graph, and I'm just going to use an equation sign because you're used to seeing that, and then we'll take into account the inequality sign. So say we had y equals 5 minus x. We studied lines. We know this is a line. You may be more familiar with it in this form, negative x plus 5. They mean the same thing. This is a parent graph. The y equals negative x is the parent graph. The plus 5 tells us to move the graph up 5 units from 0, 0. So we go up 5 units. And so 1, 2, 3, 4, 5. Put our first point there on the graph. And then we need another point. And then we got our line. And you can get a point by plugging in any x value you want. So say we plug in x equals 1. Then y is going to equal negative times 1 plus 5, which is negative 1 plus 5, or 4. So we plugged in a 1 for x, got a 4 out for y, plot that point, and now we know if we draw a line through that, we have our line. This is the point where we got to stop and say, okay, it's not an equation. I got to go back up and okay, is it going to be a first question here? So question 1, is it going to be dashed or solid? So we look at our symbol. We have a less than or equal sign. Because it has that equal, it's going to be solid. So we graph it just as is. And then the second question is the shading. Here's question 2. Should we shade below or shade above? And again, it has to do with the sign. So read the sign here. This says y is less than or equal. So if it's less than or equal, you're shading below. Now, for your purpose, hold off on the shading. I'm going to shade mine, but don't shade yours yet. And I'll explain why in a second. So shade everything below is where the shading goes. Something like that. We have a second graph now. And we've got to think y equals 3x minus 4. So the y equals 3x is the parent graph. The minus 4 drops us down 4 from 0, 0. 2, 3, 4. So our first point we put on, and then pick another x value to find out what y is. I plugged in a 1, and I get 3 minus 4, which is negative 1. So x is 1, y is negative 1. Pause before you draw this graph. Look at the sign. It says y is greater than. It's not equal, it's greater than. So this is, when we say solid or dashed, it's going to be dashed because it's not equal at that point. Something like that. And then we ask, should we shade above or below? Well, it says y is greater than. If it's greater than, you're shading above. So I'm going to, again, hold off on the shading until I give you the go. Don't shade yet. Okay, there we have it. Now our solution is where the shadings are both at the same time. Okay, if you notice in this region in here in the fourth quadrant, you just have the blue, or right up here at top you just have the green, or over on the right you don't have any shading. So the solution is not in any of those spots. The solution is where both shadings are at the same time. So I'm going to get rid of my shading and just shade where both shadings would be at the same time. That's right in this region. This is now you can start shading. And so what this means is if you pick any point in this highlighted region, it will satisfy both equations. Okay, for example, let's pick an easy one. Say right here. That point is at negative 1, 1. Okay, that's a solution to this system. We have two things. We got y is greater than or equal to 5 minus x. So, and then the second one is y is greater than 3x minus 4. So I'm claiming that negative 1, 1 is a solution to this. We can check. If I plug in 1 for y, I get 1 is less than or equal to 5 minus negative 1. Well, that's 1 is less than or equal to 6. That's true. And let's try the second inequality. Plug in 1 for y is greater than 3 times negative 1 minus 4. 1 is greater than, that's negative 3, and negative 4 gives us negative 7. That's also true. 1 is greater than negative 7. So if you could try this out, but all these points that I highlighted in yellow are all solutions. And we want to pick 2 points. We got one of them. Pick another easy one, 0, 0. Okay. You got to be careful when you get close to the lines for 2 reasons. One, your line may not be straight, and it may look like the point is part of the region, but it may not be. Second thing, if you pick something along the dotted line, that's not going to be a solution at all. Anything on the solid blue line, well, anything in the shaded that's touching the shaded region and on the solid blue line would also be a solution. So like the 2 points we used to graph, if I plug those in, it would work out for us. So anyhow, we are done with that first problem. So now is a good time maybe to pause this video and see if there's any questions. You can help each other out with this if you do, or maybe rewind and go over a part if you need to. Okay, let's go to question 2. So first graph, think of it as an equal sign first. So y equals negative 5. Hey, this is the nice one we like. It's a horizontal line at a height of negative 5. So 1, 2, 3, 4, 5. I'm going to put a point there, and then we got to decide our 2 questions. First question, should it be solid? Should it be a solid line or a dashed line? And you say it should be solid because this symbol has an equal sign. Okay, and then second question, shade above or below. And what I'm going to do here is I'm just going to write it and we'll shade later. And I'm going to say shade below. Okay, so we're going to hold off on the shading, but I'm just going to reference this when I'm ready to shade. Okay, so now our next graph. Okay, y, think of y equals x minus 4 squared minus 1. This is not a line. Do you guys remember what shape this is? It's a parabola. And it's taking the parent graph and shifting it or translating it to the right 4 units and down 1 unit from 0, 0. So that puts us at 1, 2, 3, 4 down 1 here. That's our vertex. And then let's pick another x value. We have the x value at 1, 2, 3, 4, so let's maybe plug in x equals 5 into this equation. And we end up with 1 squared minus 1, which is 0. So 5, 0 is a point that our parabola goes through. So that's the right half of the parabola. Remember, it's symmetric, so we can match it on the left-hand side. And I shouldn't have drawn it in yet because I didn't ask the two questions yet, did I? The two questions are solid or dashed. And this one should be dashed. So dashed, what we mean by that, something like this. Okay. Because that symbol does not have an equal sign. And then we want to decide shade above or below. And this one's going to be to shade above because its y is greater than. What we mean by above when we're graphing this in this particular shape, it would be everything inside the parabola. Okay, so we want to be inside the parabola, above it. Okay, I'm going to just draw on here and I will be erasing this. So I want everything in here, and at the same time I want it to be below the line. Is that possible? To be up inside that parabola and at the same time below the horizontal line? No. So in this case, if we look back at the instructions, we say if the solution exists, okay? And so we're finding there's no points that meet both those requirements. And so we're just going to state that the solution does not exist. Don't shade anything because there is no intersection. Again, this is a good spot to pause this video, see if there's any questions, make sure that we understand why a solution does not exist here. Number 3. Start with the first one, y equals the absolute value of x minus 2 plus 1. This is, you get your V shape, right? It's been translated to the right 2 units and up 1 unit from 0, 0. That's the vertex of the V shape. And then let's get another point. Maybe plug in x equals 3. And we get y is the absolute value of 3 minus 2 plus 1, which ends up getting you 2. So we plugged in a 3, got 2, plot that point at 3, 2. That's the right side of your V shape. Should it be solid or dashed? Hopefully you're saying solid because of that symbol has an equal sign in it. So solid. And we symmetric, so we can match the V shape on the left hand side as well. And there we have it. Okay, on to the next one. Y is equal to 5 minus absolute value of x minus 1. May not look familiar if you rewrite it this way. Y equals negative absolute value of x minus 1 plus 5. Those are equivalent expressions. A little more comfortable with this way maybe. This is a translation right 1 unit, up 5 units from 0, 0. Right 1, up 1, 2, 3, 4, 5. Right here is the vertex. Let's get a second point to get this shape here. So plug in x equals 2. And we end up with negative 1 plus 5, which is positive 4. So we plugged in a 2, got 4, 2, 4. It's right here. So this V is pointed down. And I forgot to ask that important question again. What is that important question before we start this graph? Should it be solid or dashed? And this one should be dashed because it doesn't have the equal sign. It's symmetric, so we got our left-hand side as well. Okay, we kind of ignored the shading, but we can't forget about it now. The blue graph, the first one we did, should we shade above or below? Hopefully you're saying below. Okay, because it's a less than sign. And the green, shade above, because it's greater than. So we want above the green, below the blue. Pause this video right now and decide where that shading is, and go ahead and commit to that spot. When you got it, okay, hopefully you got it. Let's see. If it's above the green and below the blue, well, this spot right in here, everything in here is above the green and below the blue, so that's one spot you should have shaded in, and it just keeps extending. And then here's another spot over here. So everything over here is also a solution. So lastly, we're going to pick 2 points that are in these shaded regions. Something you know for sure is going to be in that. Something easy. Here's a point at 1, 2, 3, 4, 5, 6, 7, 2. You can check that. I'm not going to take the time to do that right now, but it would work out. And I'll pick, I don't know, that one right there. At negative 1, 2, 3, 4, up 1, 2, 3, so negative 4, 3. But anything in the region would work. You can even use decimals. Number 4. Here we have 3 inequalities, but it's going to work the same way. This time we are just looking for the region where all 3 intersect. So let's go one at a time. Our first one, the easiest one, we're going to graph y equals 1. That's a horizontal line at height 1, and we just got to decide, should it be dashed or solid? In this case, it's going to be dashed. And we're not going to shade quite yet, but we got to decide shade above or below. And in this case, we're going to shade above because its y is greater than. Okay, next inequality, y equals 3 to the power of x. That's an exponential function. It's a parent graph. And if you remember, the exponential functions, the parent graph goes through the point 0, 1, because if you plug in 0 for x, you get 1 out for y. 3 to the power of 0 is 1. And then we need another point. So say when x is 1, we get y is 3 to the power of 1, which is 3. So 1, 3 is another point we can use. And it's just going to, well, should we do dashed or solid? It's going to be solid. So it's going to be rising to the right. And then remember, it gets closer and closer to the x-axis, but never touches it. Something like that. And here we want to shade, it's less than or equal, so we want to shade below. We got one more to graph. Y equals negative 2x minus 1. That's going to be a line, and the y equals negative 2x is the parent graph part, but it's been dropped down 1 unit from 0, 0. So that gives us our y-intercept there. If we pick another x value like x equals 1, we get y is negative 2 times 1 minus 1, which is negative 3. So 1, negative 3 is another point we go through. And this is going to be a solid line. And we're going to shade above. Okay, so we want below the blue curve, above the green, and above the black line. So go ahead and pause this video and decide where to shade. Once you've decided, then start it back up. Okay, so let's see. If we're above the green, below the blue, and above the black line, that would be right in this region here. Because this meets all 3 requirements, and it just extends. It's above the green, above the black line, but below below the blue. Okay, so eventually the blue will be above all that region. So then we're going to pick 2 points in that shaded region. Let's see, over at 1, 2, 3, up 1, 2, 3. So 3, 3 works. And maybe this one right here at 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. And I'll put those 2 points in here. So 3, 3, and 9, 3. All right, last one, number 5. Our first graph, we have y is less than or equal to the absolute value of x minus 2. But instead of using the less than or equal sign, let's use an equal sign to start us off. This is a V shape, drop down 2 from the parent graph. So vertex is at 0, negative 2. Pick another point to help us get that V shape. Say x is 1, we get y is absolute value of 1 minus 2, which comes out to be negative 1. So 1, negative 1 gives us the right side of that V shape. Should it be dashed or solid? Well, our inequality sign contains an equal sign in it, so we are going to be solid, which just is telling us everything on this line is also a solution to that inequality. And we're going to shade below. Okay, the second one. So the second equation, we have y equal to 2x squared minus 5. That's quadratic because we have our x squared. That minus 5 drops the parent graph down 5 from 0, 0. So we're going to have a vertex at 0, negative 5. Then let's plug in a point, maybe x equals 1. And we get 2 times 1 minus 5, which is negative 3. So that gives us the second point at 1, negative 3. Solid graph. Something like that. And then we want to shade above. So again, you may want to pause this, take a little bit of time to think, where would that shading go? So that shading, if we're below the blue but above the green, that's going to fit right in here. So it's a smaller region. You got to be careful when we pick out what 2 points create our solution. So we can pick the point at right there at 0, negative 3. And then right below that at 0, negative 4. And there we have it. Enjoy your homework.